Hello everyone, in this lesson we'll continue in trigonometry by with new idea which is called polar coordinates. So we have two objectives: identify polar coordinates and then change polar to Cartesian coordinates. Cartesian coordinates which are the x, y that we know them already. So polar coordinates, one way to give someone directions to tell them to go 3 blocks east and 5 blocks south. For example, if you want to draw an x-axis, y-axis here, so to go east 3 blocks, for example, 1, 2, 3, and then 5 blocks south, for example, south 1, 2, 3, 4, 5. So here, so we can represent this location by two ways. The first one, which is called the Cartesian coordinates, so it's 3 minus 5, 3 minus 5, that we already know from functions. Okay, so and the other one which is called polar coordinates. Okay, so polar coordinates means that each point or this point can be determined by a different way from 3 minus 5. For example, so from the origin, if we draw this line, we can measure this, or we can call it OM, for example, and the angle, let's call it theta also, for example. So any point on the xy plane, okay, any point on the xy plane characterized by its radius or the distance from O to the point and the angle between the line OM and the x-axis. Okay, this is what's called polar coordinates. So in the polar coordinates I need OM, which is the radius, and the angle. So if I give you the radius and the angle, okay, you can know the location of the point M on the xy plane. Let's take an example. In the plane, the direct orthogonal plane OIJ, we consider the point MXY. This is the point M. هذه point M. في عندها coordinates X, which is this one, X, and Y, which is this one, this line, Y. So let's say that OM equal P, small p, and the angle between x-axis, the positive x-axis, and OM is the angle theta. Okay, so if we write here cosine theta, what does cosine theta equal? Cosine theta equal the adjacent over the hypotenuse. So the adjacent is x, which is this one, in this triangle, since we have 90 degrees here, over the hypotenuse, which is OM. Okay, so this gives that x equal OM times cosine theta, which is P times cosine theta. So x of the point M is equal P, which is the radius, or let's say the distance OM from the origin to the point M, times cosine theta, the angle between x-axis and OM. Same for sine. If we write sine theta equal opposite over hypotenuse. So it is opposite over hypotenuse, يعني opposite, which is this line, which is the same as this line, so it's y, over the hypotenuse, which is OM also. So this gives that y equal OM times sine theta, which is equal P times sine theta. So we can deduce here that there is a relation between xy, which are called the Cartesian coordinates, and p theta, which are called the polar coordinates. So there is a relation between the Cartesian coordinates xy and the polar coordinates, which are p, or the radius OM, and theta, the angle. The relation is xm equal p times cosine theta and ym equal p times sine theta. Those are the this is the relation between Cartesian and polar coordinates. So if I give you the radius p and the angle, you can directly know the Cartesian coordinates and vice versa. So let's take an example. Let's take an example. Thus you must memorize them well. X equal p cosine theta, y equal p sine theta. Let's take an example in this. Here in a plane and direct orthonormal system OIJK, determine the Cartesian coordinates of the point A taken on a circle O of center O and radius 2. So the radius here is 2. Okay? Such that IOA, yani it means that the angle between the positive x-axis and OA is pi over 3. So this is the angle theta that we want, and this is P, which is the radius. Okay, so we have the angle theta equal pi over 3, and P, which is the radius, equal 2. Since it's the radius, he said the radius is 2. Okay, so simply we write XA equal, let me write it here, P cosine theta only. So P, which is 2, times cosine theta, which is pi over 3. And just we use calculator. So it will be 2 times half, so it's equal 1. And y theta or ya equal P sine theta, which is equal P times sine theta. P is the radius, and sine theta, which is sine radical 3, sine pi over 3, so it's equal to radical 3 over 2. 2 times radical 3 over 2, which is equal radical 3. So the point M has two coordinates. The polar coordinates are P and theta, and the Cartesian coordinates are 1 and radical 3. Okay, those are called the polar coordinates, and those are called the Cartesian coordinates. Let's take some exercises, small, just little. Just two exercises, number 7 and number 8. Consider OIJ, direct orthogonal system U, such that magnitude of U equal 3, and the angle between I, which is the positive x-axis, and U is minus pi over 6. So if you want to represent it here on just quick sketch of the point that we have here. So we have a circle of radius 3, so the radius equal 3. And the angle between I and U, I, which is always represent the positive x-axis, and U, which is equal minus pi over 6. So minus 30, so let's say somewhere here. Okay, somewhere here. This angle is minus pi over 6, and that one is R equal 3. So how to represent this? We write x equal, he said find the Cartesian, or determine the coordinates of the vector u. Okay, this is the vector u, the Cartesian coordinates. So let's write u equal, or xu using the same formula, xu equal p times cosine theta, which is equal 3, since the magnitude of u equal 3 and the radius is 3, times cosine theta, which is cosine minus pi over 6. Okay, so it is equal 3 times cosine pi over 6, since cosine minus pi over 6 equal to cosine pi over 6, so it is equal. You can use your calculator here to just calculate. So it is equal to cosine so it's radical 3 over 2. Just I make sure from something. so it's equal 3 radical 3 over 2, and then yu equal 3 times sine theta, so it's equal 3 times sine of minus pi over 6, so it's equal minus 3 sine pi over 6. So we already know that if we have sine minus pi over 6, we move this sign outside, so it's equal minus 3 sine pi over 6, so it's equal minus 3 times half, and it is equal minus 3 over 2. So u has coordinates, or the Cartesian coordinates, 3 radical 3 over 2 and minus 3 over 2. Okay, just make sure from the calculations here. Another one. In exercise 8, we have 2 points, E and F. The 2 points have coordinates or polar coordinates 2 pi over 6, this is point E, and point F 3 2 pi over 3, this is point F. Calculate the Cartesian coordinates of E and F. Let's start by E. So xe equal p cosine theta, يعني equal p, which is 2 times cosine theta pi over 6, so it's equal 2 times radical 3 over 2, which is radical 3, and ye equal p sine theta, p times sine pi over 6, which is 2 times half, which is 1. So the point E هذا بيعطونا إنه point E عندك coordinates radical 3 1. Point F xf equal p cosine theta, يعني p, which is 3 times cosine 2 pi over 3, which is equal 3 times. Here you can use your calculator, or you memorize it from the table, but I don't think 2 pi over 3 is on the table. So cosine 2 pi over 3 equal minus half, so 3 times minus half, so it is equal minus 3 over 2, and yf equal 3 times sine 2 pi over 3, which is equal to radical 3 over 2, and 3 times radical 3 over 2, so it's equal 3 radical 3 over 2. So the point F has coordinates, point F has coordinates x, which is minus 3 over 2, and y, which is 3 radical 3 over 2. Okay. In part 2, he said deduce the distance from E to F. We know that in EF equal radical xe minus xf squared plus ye minus yf squared, and just I'll give you time to find the calculations here, so just may use your calculator. This is xe, this is ye, this is xf, this is yf. Just use your calculator to find the distance from E to F. That's everything. Thank you so much.